All right, so we have some examples where we are going to continue looking at our adding and subtracting of radicals. So example 4, you might notice that these are not square roots. These are now cube roots. So we're going to break these down like we've broken down our cube roots before. Just remember it's a different set of numbers. I'll go ahead and write it across the top. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and the list goes on. We can add to that if we need to. So we're going to try to break these down. So we have the cube root of 250, and the reason we're breaking those down is because these are not like terms right now. Let me go ahead and make this a little bigger. So we can't do the addition or subtraction. So we have to reduce the radicals and see if we have any like terms. So the cube root of 250, so which number up there fits in? I can see the 125 fits in twice. 125 times 2 is 250. So that reduces to the cube root of 125 is 5 times the cube root of 2. Bring down your minus sign. All right, cube root of 54, which number up above fits in? Well, that's going to be 27 times 2. The cube root of 27 is 3, and that cube root of 2 stays. And then we have the cube root of 4. So which of these numbers up here fit into 4? Well, none of them do. 8 is too big, and that's our smallest cubed number, so that just means that we bring down this plus cube root of 4. We couldn't reduce it. So in this example, we have 3 terms, but they're not all like terms. So we're only going to put the ones together that actually go together. So that's going to be this one with this one. So remember that radical, the cube root of 2, does not change, and you subtract the numbers out front. 5 minus 3 is 2, and then carry down the rest of the problem, plus the cube root of 4. And that will be our final answer. All right, moving on to the next one. Well, I'm sure you're excited to see fractions. So anytime that and these are square roots, so we're back to our square roots. Square root of 3/4 can't be reduced. Square root of 27 over 4 can't be reduced. So let's go ahead and break this down. We have the square root of 3 over the square root of 4 plus the square root of 27 over the square root of 4. So that really is the square root of 3 over 2 plus the square root of 27 over 2, which gives us a common denominator of 2. So we can go ahead and add the numerators, although they're not like terms, but maybe they will be when we simplify. So that's our answer, but let's see if we can do any simplifying up here. So the square root of 3 can't be broken down, so that's going to stay. But the square root of 27 is the square root of 9 times the square root of 3. Square root of 9 is 3, square roots of 3. This is all still over 2. And then let's go ahead and combine the square root of 3 plus 3 square roots of 3. Remember, that's a 1 out front, and 1 plus 3 gives us 4 square roots of 3 all over 2. All right, so can we do any reducing with this final answer? Do you guys see how we have a 4 and a 2? Those are both what we call those outside numbers. 4 does divide by 2, and you get 2, and then the square root of 3. All right, last one, we're on a roll. All right, so similar to what we just did, we can see that we have, square root of a fraction, square root of a fraction. Neither one can be reduced, so we're going to break this down. Square root of 5 over square root of 3 plus square root of 3 over square root of 5. And I can see that for the addition problem, we do not have a common denominator. So let's make that a common denominator. If we multiply this by a square root of 5, now both denominators have a square root of 5. What does this one need over here? Well, it needs a square root of 3 on the top and bottom. So we have a square root of 5 and a square root of 3. Square root of 5, square root of 3. So let's rewrite our problem. On the top, square root of 5 times square root of 5 is the square root of 25, which is 5. And then on the bottom, the square root of 5 times the square root of 3 is the square root of 15. plus. Now on the top, square root of 3 plus the square root of 3 is the square root of 9, which is 3 over the square root of 15. Well, now we have that common denominator that square root of 15 is going to stay. 5 plus 3 is 8. And we have that square root of 15 on the bottom. So now, how does this look for our final answer? Well, you might be thinking, I don't know, it doesn't look right with that square root of 15 on the bottom, and you would be right. We can't leave the square root of 15 on the bottom, so we have to rationalize this. So we multiply the top and the bottom by the square root of 15. This leaves us with 8 square roots of 15 over 15. And then think to yourself, can we reduce the square root of 15? Do any perfect squares fit in? 4, 9, 16, 25? No, nothing fits in. Then look at your outside numbers. 8 over 15, can we reduce that? No, we cannot. So that's going to be our final answer.